Hey mathematicians, today we're going to talk about simplifying or reducing fractions. So we've already had a conversation about finding equivalent fractions, and this video is going to be very similar to that one. But first of all, let's talk about those words simplify or reduce. So sometimes we'll get an answer in a fraction problem, and it might look like this, like 4/6. Okay, but the fact of the matter is there are some fractions that we're better at visualizing in our head than others. We're really good at picturing halves or thirds or fourths or fifths, right? But as soon as those numbers start getting a little bit bigger, tenths, fifteenths, hundredths, we're not quite as good at visualizing them. So we want to try to write our fractions in the simplest terms possible, or with the smallest number in the denominator as possible. We're not always going to be able to get it to a number as small as 2 or 3 or 4. You know, maybe we get stuck at 11 or 13, but it's still going to be better than, say, 44 or 99, right? Those numbers are really hard for us to picture in our brain in terms of fractions. So we're going to talk about how I would go about simplifying the fraction 4/6. Basically, I'm going to see if I can get this number to be a little bit smaller. So I'm going to show you the standard algorithm for how to do this, and then we'll prove it with a picture. So we'll get to these rectangles in just a minute. Alright, so if I have 4/6, I'm going to use my strategy for finding equivalent fractions. So remember, if I want to find a fraction that represents 4/6 but goes by a different name, a different denominator, I can either multiply the numerator and the denominator, or I can divide the numerator and the denominator by the same number. So let's think about this logically. If I multiply 4 and 6 by the same number, let's say I multiply it by 2. Okay, that'll give me an equivalent fraction of 8/12. Now that's all fine and dandy, but I haven't made this fraction any easier for my brain. In fact, I've made it a little bit harder because I've made the denominator bigger. Okay, I went from a 6 to a 12. So if we're going to simplify fractions, we're always going to be dividing them. We always need to divide them by the same number to make those numbers a little bit smaller. Okay, so if you'll think all the way back to our prime and composite unit from the very beginning of the year, this is where that really comes in, because we need to know what numbers go into 4 and what numbers go into 6. What are the factors of those numbers? So we know what our options are. Okay, so if I think about all the ways to make 4, I know I can do 1 times 4, and then I know I can also do 2 times 2. Okay, so those are the factors of 4. Those are the numbers that I can multiply to make 4, and vice versa. Those are the numbers that I can divide 4 by and get a nice even, or a nice whole answer. Let's do the same thing for the number 6. So I know I can make 6 by doing 1 and 6, and I know I can make 6 by doing 2 and 3. Okay, so those are all the numbers that go into 6. In order to simplify this fraction, we're going to have to divide the top and the bottom number by the same number. We'll have to divide the numerator and the denominator by the same thing. So we're going to analyze this list to see if they have any factors in common. The first thing right off the bat we're going to see is that both of these numbers have a 1 as a factor. But if you know your division facts, you know that any number divided by 1 equals itself. So 4 divided by 1 is 4, and 6 divided by 1 is 6. So did using 1 as the number to divide by get us anywhere? No, it gave us the same fraction. That's not what we want. So 1 is never going to work for us. So let's just scribble that guy out. But these numbers both do have a 2 in common. Okay, so 4 divided by 2 and 6 divided by 2 should give me a nice even, or a nice simple answer. Okay, so 4 divided by 2 is 2. 6 divided by 2 is 3. And I have made a simplified version of 4/6. I have made 2/3. Now I can't stop yet because sometimes there'll be, I could take this a step further and make it even simpler. So really quickly, I'm going to do the same process for 2 and 3, just to make sure this number is as simple as it can be. So the factors of 2 are 1 and 2. Remember, it's a prime number. Those are the only numbers you can multiply together to make 2. 3 is also a prime number, so the only way you can make 3 is by doing 1 times 3. We already had a conversation about how the 1 isn't going to work for us. And then these numbers don't really leave us with very many options, right? They don't have anything else in common. So because they don't have any other factors in common, we can say that 2/3 is the simplified version of 4/6. So I'm going to copy this up here because I want to get rid of all this work and see if we can prove that those are the same number. Okay, so I drew some fraction strips over here, and I'm going to cut one of the bars into 6ths and one of the bars into 1/3. Whoops, let's see if I can get a slightly straighter line there. Not much better. That's okay. Okay, there's my 6ths. They're a little bit wonky, but that's okay. And I'm going to make my 1/3 down here. Oh, see, those are much better. All right, so let's color in 4/6 on this top one. 1, 2, 3, and 4. All right, that's 4/6. Let's color in 2/3 on the fraction bar beneath it. Okay, so I've drawn 4/6 up here and 2/3 down here. Using my picture, I can prove that these fractions represent the same amount, right? But 2/3 is a much simpler way of representing this amount, right? I'm dealing with smaller numbers that my brain can visualize. I'm dealing with fewer pieces, and I can really get a better mental picture of what this fraction is. Okay, so that is the standard algorithm for simplifying fractions with a picture to prove it. So anytime you solve any any fraction problem, be it addition, subtraction, multiplication, or division, you need to double check that your fraction is written in simplest form. If you feel like that's all the information you needed, you can go ahead and click out of this video. If you want to take it a little bit further, we're going to work with a slightly more complicated fraction now. Okay, so I'm going to get rid of 4/6, and I'm going to make a fraction, let's say 13/50. Ooh, that's a big number, right? 13/50. Let's see if this number is written in simplest form. Okay, so our first instinct might be to look at this number and say, I can't do that in my head. I can't do that quickly. I'm just going to circle this as my answer and be done. But that reasoning that you just gave is precisely why we have to find a simpler version if there's one out there. Because I don't know about you, but I don't know what a 52nd looks like, right? I can't picture that in my head, so I've got to simplify these fractions if possible. So just like before, I'm going to start by listing my factors of the numerator and listing my factors of the denominator. 13 is a prime number. I remember that from the beginning of the year. So the only factors are 1 and 13. So I better hope that 52 has 13 as a factor or I'm going to be in trouble, right? So let's do the factor list for 52. 1 and 52 are going to start us off, right? Because every number has those factors, okay? 52 is an even number, so I know 2 times something equals 52. I could come over here and do some long division to check what that number is. 2 goes into 5 2 times. subtract, bring down. 2 goes into 12 6 times. 6 times 12 times 2 is 12, which gives me 0. All right, 52 divided by 2 is 26. Okay, so we'll go ahead and put 26 here. Let me get rid of this work. All right, I don't know if 3 goes into it, so I'm going to check really quickly by skip counting. I know that 3 goes into 60, right? 3 times 20 is 60. So I'm going to take away 3, gives me 57. That's not the right number. Take away 3 again. That gives me 54. I'm going to take away 3 again. That gives me 51. Yeah, it doesn't look like 3 goes into 52, so we'll go ahead and get rid of this work. Let's see if 4 goes into 52. I know that 4 goes into 40, right? That's 4 times 10. So I can just keep adding 4s to see if I get to 52. So there's 48. I'm feeling good about this one. If I add 4, I get, ding, 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 52. So I'm going to count up how many times I would have to skip count by 4 to get to 52. So there's 10 of them right here, right? Here's my 11th. Oops, I skipped one. Here's my 11th. There we go. Here, this one right here is my 12th. And so this guy is my 13th. So I'd have to do 4 13 times. Now there could possibly be some factors that I've missed, but really I was on the hunt for the number 13, right? Because that's the only factor that 13 gave me to work with. Okay, so 13 goes into 13 and it goes into 52. So we're going to divide the top number and the bottom number by 13. All right, 13 divided by 13 equals 1. 52 divided by 13. Remember when I did that skip counting, right? What was the factor pair that went with 13? Oh, it was the number 4. So 52 divided by 13 equals 4. So even this big, messy, complicated fraction, 13/52, can be reduced into something as simple as 1/4. So that is why it's so important that with every problem we do that involves fractions, we check to make sure that we have simplified the fractions at the end. Hopefully that gave you a little bit more information about how to simplify or reduce fractions, and I can't wait to see you put these skills to work.